In this video, we'll learn how to design a function to parse data from our information source. As we saw in the last video, our course library has a function parseInt that can parse an int from a string, and a function parseFloat that can parse a float from a string. But what if your information source has data that is best stored in a user-defined data type, like an enumeration or an optional? In those cases, just like in the int and float cases, the CSV reader will read the information as a string and will need to convert it to data of the appropriate type. In this video, we'll design a function that can parse an enumeration, but the same ideas would apply if you need to parse an optional. We'll work with a file from the City of Vancouver that contains information about public art installations. Here's an overview of the information that this file has. As you can see, the file contains many pieces of information about each piece of art. Here is the file. We'll focus on the information about the artwork's status, whether it's in place, i.e. displayed in the community, removed, or under review. You can see this in the column labeled D, status. We have designed a data definition to represent this status, and you can see it's an enumeration. This video will focus on parsing the enum, so we do not show the entire How to Design Analysis program and all its data definitions and functions. If we were going to design the entire program, we'd need a data definition for a piece of artwork, which would reference the public art status type, and we'd need a data definition for a list of public artworks, which would reference the artwork data definition. We'll focus in on the lines of code that we'd use in the read function to read the information from the file and convert it to data. Here is a snippet or a few lines of code from the read function. In this video, we'll focus on line number 4, so we'll delete the rest. But now you have the context to remember where this line comes from. When we're reading the information from the file and converting it to the appropriate data types, this is the row that we would need to update. So if we imagine that we had an artwork data type, our goal is to create a new piece of art. So a new individual or one piece of art. And then if you remember, this line was in the context of a for loop, so it would get repeated, creating one artwork for every row in the information file. As we can see, we need to read in some number of columns. We don't know how many. Row at 0 represents the leftmost column or the 0th column. And then we read in some number of other columns. The column that we're currently interested in is the third one. So I'm going to just change the others to ... meaning we would probably want to read in some columns before the third column and after the third column. But at the moment, we are just focusing on understanding how to parse a public art status from the string that the reader will give us. So we know that this row at 3 will give us the string from the third column in our information file. Let's flip back to remember what those could be. So if we look at our third column, again remembering that we start counting at 0, that is the status column. So I can see that it's either going to be the string in place, starting with a capital I and a space between the two words, the string removed with a capital R, and we know that there's a status under review. So let's find that D. So here we see it's under review with a capital U and a space in between the two words. So now we remember, or now we know, what strings we're going to get from our CSV reader. And that will help us design a function that can convert those strings into a public art status. We need to design a function to do this parsing. I'll call it parse status, and I'll put it on this line just as an indicator of how we would use it. So I would call parse status, and I would pass it the string in the third column of my CSV file. So an individual string. Now let's work on this function design. So we're calling it parse status. It takes one input, which is a string, and it needs to return a public art status. For the purpose, we could say convert S to a public art status. And for the stub, we'll just write return, and then we can pick any one of the statuses. I'll pick in place. Now we need to do our examples. When we're considering how many examples that we need to create, we consider the input type, we consider the output type, and we want to make sure that we cover any meaningful variations in behavior of the function. In this case, because what we're doing is converting a string to an enumeration, and that enumeration has 3 cases, we should have exactly 3 examples, or exactly 3 tests, one for each of the cases. So if parse status took in place, I would expect it to return public art status in place. Then I'll just copy these. I'll copy this and change the wording. So we also had removed, and we also had under review. And those would return removed and review. Before I run this, to check if my examples have any errors, I'm going to comment out this line, because we don't have an artwork data definition defined. This is just how we would use it in the context of our larger program, but we don't have that here. So I'll comment that out. Let's run this function. And we get no errors, but we do get test failures, which as always is what we expect. We haven't completed this function design yet. So now we'll move on to the template phase. I'll comment out the stub. And my input type is S. So my template then is based on atomic non-distinct, and it's just returned ... S. I'm going to scroll a bit so that we can see our data definition and our function design at the same time. Although our template is just return ... S, we can take some guidance from our enumeration template, because we know that there's going to be 3 cases. If the string equals in place, which I can also see in my example, our function should return public art status.inplace. Otherwise, if the string equals removed, it should return public art status.removed. And in the last case, if it equals under review, it should return public art status.review. So I know that I need to have an if-elif in here. So I'm going to remove the return for now. And I'll say if S is equal to in place, then I want to return public art status dot in place. So I'm using my examples and taking some motivation from my enumeration template. Otherwise, if it equals removed, I want to return public art status dot removed. And in my last case, if it equals under review, I want to return public art status dot review. So now let's run again, make sure we haven't made any errors, and all of our tests pass. So that is an example of how we can parse a user-defined data type. We had an enumeration data type, and we needed to take in a string that our CSV reader read from our information file and convert it to our user-defined data type. You would do something similar if you were trying to parse an optional type.